Hi everyone. In this video, I'm going to go over an example of how to use the Make program. So Make is a build automation tool that can be used in order to define rules for compiling and running your project. So if you have a project and let's say it only has one file in it, maybe a main.cpp, kind of like you can see here on my screen, then you might think, why do I need another program to help me build and run my program? It's so small, right? Or it's all in one file. Well, that's true, but as your software projects get larger and larger, you're probably going to have a lot of files to compile, which can make your G++ command really long, right? It can also make it really inefficient if, let's say, there's 100 files you need to compile and you only make a change to one, right? Do you really need to compile all of those files or just the one that was most recently changed, and then you can link with the object files from the other source files that have already been compiled? All right, so we're gonna kind of make a little example here, and then we're gonna compile it using G++ and run it using /a.out, and then we're gonna redo it using Make, okay? That way you can see the application of Make. All right, so what I've got open here are 3 files as part of the 3-file format, which is kind of a nice step from putting everything in one file to breaking that up into 3 files that include the use of something called a header file. Okay, so I've got this little main here. All it does is print out hello. Okay, at the top I'm including structs.h. So let me show you structs.h. So here's structs.h. It's got some header file guard code to prevent against double inclusion of this file, which can give us compiler errors. It's including iostream for cout. It's using the standard namespace, also for cout. And then I just made some little comments here. If I had some constant global variables or struct or class or enum definitions or prototypes, I would put them in here. Okay, so let's say I had a function, maybe something like print hello or print array. Okay, I would put the prototype for that function here, and then I would define it in the .cpp file of the same name as the header file. Okay, so main.cpp, all it has is the main function. All other functions would go in the .cpp file. Now you might be wondering, why did I call this, the structs fun folder? Why do I have structs.cpp, structs.h when there's no structs here? Well, I'm kind of saving a little bit of time because my next video is going to be an overview of how to use structs in C++. So I'm kind of breaking this up already so that I can use this for my next video. But for your 3-file format, if you're working with arrays, you might call this arrays.cpp or maybe functions.cpp, or maybe it's a homework assignment for a class. You might call it like homework4.cpp and homework4.h, etc. I can name these files whatever I want. The key is just to make sure that I use the header file in both of my source files, because these source files need things like #include and using namespace standard. All right, so let's compile this. So here's how I would compile this. I only compile the .cpp files, the .source files, or the source files. So main.cpp, structs.cpp. Great, this produces an a.out, which I can run with /a.out. And there you can see hello is shown. Okay, that's coming from this cout statement in main right here. Okay, so now let's say we want to do this G++ ./a.out process again, but this time using a simple make file. Okay, so the make program or the make tool, when you run it, make, okay, it looks for a file called a make file. So we have to create a make file in this folder, and then in that make file, we have to provide the commands or the terminal commands that we want to execute when we run the make command, okay? So I'm gonna open in gedit. You could open this in any text editor you want. A file called makefile. And note that the M is capitalized. So capital M makefile. Make sure it is spelled and looks exactly like this. All right, so here's my empty makefile. And what I'm going to do in here is take a little bit of comments and then show you how to write a simple makefile. So in makefiles, the pound sign or the hashtag symbol denotes a comment, okay? So I'm going to start with a comment, and I'm going to say that a makefile is a script that contains rules, okay? Oops, there I go again, starting to write comments in C++. All right, pound sign, comment. So the rules define how to compile and run your project. You can have as many rules as you want. So the first rule in the file, okay, this is important, is the one that is executed when you run make, okay? To run other rules, use their name after make, okay? So it's kind of like you pass in a command line argument to specify which rule you want make to execute. If you don't pass in a command line argument saying which rule to execute, then make is just going to execute the first rule in the file. So let's write our first rule. We'll call our first rule all, okay, A-L-L colon, okay? Then I'm going to press enter, and here's the key. I'm going to press tab, okay? I'm going to press tab. Now this can give you some trouble if you're in an editor that actually doesn't allow you to insert tabs. If you press tab, it might insert like 4 spaces. Okay, make probably isn't going to be happy with your makefile if it has spaces instead of tabs. So just a heads up on that. I really am pressing tab, you can see. All right, now I'm just going to type that exact same command that I wrote at the command line where I'm compiling structs.cpp. Okay, so this is going to compile G++. And for my all command, I'm going to run and build at the same time. So here's my build command to compile, and here's my run command to execute. All right, that's it. So now when I type make, it's going to compile and run in the same execution, the same command. It'll be really awesome. All right, so I'm going to run make, and let me clear this out. Try again. All right, make, and there it's showing me it's compiling, it's executing, and there's my output. So now I just saved myself a bunch of time because I don't have to keep flipping up, finding, okay, compile, wait for that. Okay, execute, wait for that, right? I can just do it all in one. I could also do make all, and I'll get the same output. Okay, so here's where I'm specifying the rule that I want to be executed. Now let's make this a little bit more interesting. Let's say that my program actually produces, say, multiple executables, and I want to name them, okay? There's a flag or a switch in G++, -O or -O, where I can pass in the name I want to provide for the output file. So instead of a.out, which is the default, I want to say call this, I'll say run structs fun. Okay, so this line right here is going to produce an executable called run structs fun instead of called a.out. So now I'm going to run structs fun instead of running a.out. Do an ls, and there's run structs fun. So you can see as your projects get bigger and bigger and you've got lots of files, you might be producing multiple executables, naming them something different, and maybe having different rules that determine which ones are going to be run. So let's try adding a few more rules. My all rule does everything, right? It compiles and it runs, it builds and it executes. Maybe I might want to just break this up and have one compile rule, and I'll just copy and paste this. And maybe I just want to have one run rule. Maybe I don't want to do them together, or maybe these are different rules. One, for a subprogram of your program, one for different architecture, one for debug, one for release, etc. All right, so I'm just going to run make. This is doing make all. I can do make compile. It will only compile. And I can do make run, and it only runs. All right, so that's my brief overview of make and makefile. So just to recap, Make is a build automation tool. You can use it to execute make files, which are essentially scripts that have rules that you can use in order to define, different types of building and execution for your projects. As your C++ and your C projects get larger and larger and larger, you're definitely going to want to turn to using make and make files in order to manage building and running your large software project. All right, that is all for now. Thank you for watching.